This video is about dipole moments and polarity. We're going to do this in about 3 videos or so. To do this, you're going to have a periodic table in front of you, and you must remember that electronegativity increases as you go up and to the right. Very important that you know that. We're going to define polar, and polar means two poles, or dipole means two poles, dipole. And we talk about a molecule such as C triple bond O, CO, there's the Lewis dot structure, which you should know how to do. And this bond is said to be polar because oxygen is more electronegative than carbon. And so we put these symbols down. And this first symbol here means partially positive on the carbon end and partially negative. What this means is when we bond the carbon and oxygen, most of the dipole, or a lot of the electron density, is over here on the oxygen and not very much on the carbon. And so we say the bond is polar. And we draw a dipole vector that looks like this. These are very specific. We got an arrow and we got a vertical line over here. And notice it is not on the end. You don't put it out here. You do not draw these like this. That is not a dipole vector. We're very specific about that in chemistry. Okay? And so this bond is said to be polar, and the molecule, or the bond, is said to be a dipole, polar bond, and we have a polar molecule. So polar bond means we have a plus and minus part to the bond. A polar molecule means the molecule is completely polar. Well, not completely, but it has one plus end and a negative end to that. And we'll see examples where a molecule is not polar but has polar bonds. And these are said to have dipoles, which means you have a bond that doesn't share or shares electrons unequally. So let's do some examples here. And you got to have your periodic table in front of you all the time. Here's an example, HCl, and you should rapidly know that chlorine is more electronegative than hydrogen, so this will be a polar bond. It'd be a polar bond and a polar molecule. We have partial positive, partial negative, and a partial positive here because chlorine is more electronegative than hydrogen. Here's another example. Cl bonded to Cl. This is an example of a non-polar bond and a non-polar molecule because chlorine shares with chlorine equally. Okay? Neither chlorine grabs the electron density more than another. A couple more examples. C double bond O. There's the Lewis dot structures. And now remember, I've drawn the whole Lewis dot structure. We've got some electron pairs out here. They don't have anything to do with the polarity. The polarity is part of the bonds between the atoms. So when we look at this one, and I'll draw it like this so we can think about it, we have a partial negative, partial positive, and partial negative because oxygen is more electronegative than carbon. This means we pull electron density this way and we pull it this way. We have pull in both directions. We have dipole in this direction and an equal and opposite dipole in the other one. And so these vectors are exactly opposite of each other and they cancel. So this has polar bonds, but it's non-polar. Okay, that's all I'm going to do in this video, and I'll give some more complicated in the next one.